Hello, my name is Matthew Schulman, and I will be presenting our presentation today on using machine learning techniques to predict RT-PCR results for COVID-19 patients. This project was put together as an undergraduate study for the IT capstone for information technology. The members of the team consist of DeMonte Moore, Thomas Phillips, Andy Reynolds, myself, India Andrews, and Bradley Durden. We also had advisor Amin Poria. In late December of 2019, a variation of the coronavirus, SARS-CoV-2, emerged from Wuhan, China, and very shortly became a global problem, leading to the global pandemic we are in today. Currently, testing for the SARS-CoV-2 strand takes a long time and is costly to perform. If a quicker, more efficient method were created using machine learning to easily diagnose COVID-19, it could dramatically help reduce the spread, especially for countries lacking resources. The goal of our paper was to review different supervised machine learning techniques in the Weka environment to see if machine learning techniques could be used to predict the outcome of COVID-19 in a patient presenting symptoms. We analyzed the dataset provided by the University of Milan from Dr. Thomas Langer and Dr. Maria Favarto and applied different machine learning algorithms with different settings. We then compared these results to the baseline result from the paper published by Dr. Langer and Dr. Favarto. Our experiment plan consisted of 3 experiments, all of which we use 5-fold and 10-fold cross-validation, as well as an 80-20 split, where 80% of the dataset was used for training and 20% was used for testing. Experiment 1, we use all 81 attributes that were provided from the University of Milan that is comprised of all the data they collect in their patient portal when a patient is admitted. Experiment 2, we use feature selection in Weka on the 81 attributes to get it down to only 14 attributes with high correlation. Experiment 3, we manually extracted the attributes from the dataset that were published in the paper we acquired the dataset from. Here is the results of our first experiment, as you'll see it compared to the baseline. We did achieve higher than the baseline with an accuracy of 87.5 using rotational force and 80-20 split. This is our second experiment using attribute selection, which achieved quite higher results on many models, in getting 85% on several with 87.5 accuracy using naive Bayes. Our third experiment, we used the attributes from the twist method and achieved our highest accuracies both from rotational forest and naive Bayes with an 80-20% split. In conclusion, we believe after our experiments that an application could be developed using only 14 or 41 attributes that are easily available to any ER in the world. Using naive Bayes or rotational forest machine learning algorithms, we can predict COVID-19 in patients that are admitted to the emergency room much quicker and more cost efficient. We are targeting our paper to be submitted to the IEEE Conference on ICT Solutions for eHealth.